Hello everyone, in this video I want to go more in depth on the first stage of the Breadboard Superheterodyne AM radio, and so I'm going to be looking at the input filter and the mixer stages of the circuit, and I'm going to be building that here on the breadboard and showing how that works. So let's get started. So first of all, the input filter is constructed of three RC high-pass filters. The first one being, we're going to start with this 4.7 nanofarad capacitor, then this 220 ohm resistor. I don't remember the exact frequency of all of these, but they result in a high-pass filter that basically cuts off everything below the AM broadcast band, and I'll discuss that later. I'll show a plot of the frequency response of the circuit. So the next, then we have this stage of it, where we have this capacitor is a 0.1 and a 180 ohm resistor going to ground, and then another 0.1 with a 470 ohm resistor going to ground. Let me just make sure I got that right. Okay. And so that is our input filter. Let me just get the antenna connection. The antenna I'm using is just, well, my bench, the metal frame of my bench. So let me just see if I can pan up and show that. So you see this wire I've got here. Well, you probably can't see it. This wire here. So you see this wire here connects to this alligator clip wire, which there's a whole bunch of black wires there. You can't see it, but it connects to this white wire that goes in front of the oscilloscope. And that wire connects to the metal frame of my bench and acts as an antenna. So now I'm going to connect the antenna to this input right here. So the next part is the mixer. For the mixer, we'll be using this chip here. This is an NE612. It's just an RF mixer, and I'm just going to put that right there. For this chip, first of all, we want to connect power and ground. So ground will go to pin 3 of the chip, and power goes to pin 8. So after we've connected the power and ground, we want to connect the input signal, and the input signal goes to pins 1 and 2. And since we're not connecting it to a transformer, we're just going to use the first input and then capacitively couple the other input to ground. So I've got this 0.1 microfarad capacitor, and I'm going to use this to connect the input signal into the mixer. Then we'll take another 0.1 microfarad capacitor and connect that to ground. The next step is to connect the oscillator, and that also needs to be capacitively coupled, and we're going to capacitively couple that to pin 6 over here. So we'll just leave a little bit of space for a potentiometer. And for the potentiometer, I'm going to use this one right here, and that's a I believe 10 kilo ohm. But for this purpose, it doesn't really matter what the value is. It just can't be that low of a resistance total. So this is for controlling the amplitude of the incoming, like from the oscillator, because this mixer likes to have a local oscillator that is between about 200 to 300 millivolts peak to peak. So we want to keep it happy, and we want to make sure that we're not distorting our output signal. So that's why we have this here. I'll be using the function generator for now, so we don't really need that, but I'm just demonstrating what's in the radio circuit. and just in case I want to build an oscillator of some sort and hook that up, and that's so we can get the optimal amplitude for that. And the other end of this potentiometer goes to ground, so we'll just hook that up there. And then we need to connect the oscillator. And so let's hook up the ground first. So we got the oscilloscope ground here, the function generator ground here, and here's the output from our function generator. We're going to hook this to the other end of the potentiometer here. And then now we should be able to adjust the, the amplitude that goes into the mixer, so we can get a nice clean output and get the optimal amount of gain. So now this circuit should be ready to run if we hook up power. Find 5 volts here somewhere. So here is my 5 volts and ground. Ground here, 5 volts here. So we're going to hook this up. Blue to ground, orange to 5 volts. Now the circuit should be working. There are no outward signs that it is. So let's put some signals into it and see what we get out. So now let's set up the function generator to output our local oscillator signal. So first of all, let's set up the frequency. The strongest station around is 1190 whoa. So that's on 1190 kilohertz. So 1190 plus our IF frequency, which is 460 kilohertz. That would be about 1650. So that's what we're going to set this frequency setting to here. 1650 kilohertz. And then for the amplitude, in a later part, I wanted to make a module. I wanted to make a circuit that outputs probably about 1 volt, although I'm not sure. So we'll just make it 1 volt. Since we have that hooked up and we have power hooked up, we can turn that on. And now let's see what kind of signal we get on the output. So here is our oscilloscope probe. I'm going to plug that into either pin 5 or 6. 5 and 6 are both outputs of this mixer. So we'll just plug it into pin 5, or pin 4. So those are both output pins, and let's turn on the oscilloscope and see what the output wave looks like. So one thing I forgot to do was to adjust the level of the oscillator to about 200 to 300 millivolts. So let's just do that real quick. I'm going to connect to the middle of the potentiometer, and then we'll look at the oscilloscope screen and adjust that potentiometer until we get about 200 to 300 millivolts. So we're at about 200 right now. I'm going to increase that just a little bit to 300. So that's adjusted now. Now we can go back and probe the output of the mixer on pin 4, and let's see what that looks like. So what I found out after looking at my circuit a bit more is there's a couple of issues. I forgot this capacitor right here. This is a 0.01 microfarad. This couples the output, and we'll just look at that. And there's also, well, really these capacitors don't, like these two capacitors here don't make too much of a difference as long as they're a low reactance at the frequency the frequency you want. So I just picked 1 microfarad and 0.01 microfarads here. And this one here goes from the output we're not using to ground, and this one goes from the output we are using to the oscilloscope probe. Another thing I had to do is I noticed it wasn't giving any output, and I figured, well, really that's probably because it's not getting much input. So I took this filter out of the path so we can look at it on the scope. This is just so we can look at it on the scope and show that it's working. But anyway, it is working now, and I'll show you that on the oscilloscope. So here we're looking at the FFT of the signal, or this is the frequencies contained within the signal. So right here on this cursor, we have 460 kilohertz. That is our desired IF frequency. Let me see if I can focus on that. There you go. So 460 kilohertz. That's on that marker right there. And so you can see we have a peak there. There's a couple other peaks around there. Those are the other stations on the AM broadcast band. And so looks like it's working. Now let's look at what the output of this mixer looks like. So this contains both the sum and the difference of this contains both the sum and the difference of the oscillator with every signal that is coming in. Now this isn't very useful to us right now, so we need to filter it. And I'll talk about that in the next video when I get to the amplifier. When I start talking about the amplifier, I'll also talk about the filtering that goes so that we get a lot cleaner signal than this. So now that we have this circuit built up, I think we could probably put this onto a prototype board, something like this. Probably put it on something like that. I'm not sure if we have enough space on that one. So we'll take this circuit and we'll build it on a prototype board. Make sure that still works. And then I can take it off this breadboard and also take it off my breadboard up here, free up some space. So while I was editing the video, I noticed I made a mistake here with the input filter, and that might explain why it didn't work. So I'm gonna fix that really quick, and we'll see if that works. Hook up the antenna first. Now the goal of this filter wasn't really to select any particular frequency range, but was to block 60 hertz from just the environment to block that from getting to the mixer. So we'll see. Let's get the oscilloscope probe now. The oscilloscope probe goes right over here, and we'll hook up ground just to this guy for now. Let's take a look at the oscilloscope. So here is the Bode plot of the AM radio input filter. I didn't really have any frequencies in mind. I just sort of picked some values. As you can see, they're right here: R1, C1, R2, all those values. And then I calculated the frequencies here, the cutoff frequency for each filter, converted to hertz, and then made a little transfer function, and got the magnitude of that. So here, this line here shows you where the cutoff frequency is. So it's right about here at 263 kilohertz, and down here at like tens of kilohertz, it's very low, a lot of attenuation. And then as you get into the AM broadcast band, which I have marked in blue here, this you're at the very bottom. You're losing only 9% of the amplitude. So here I've come up with a prototype circuit board. This is basically the same circuit that I just showed you on the breadboard, and just kind of planning out where all the parts go. It's going to go on a board like this. I already have all the parts selected here, all the resistors, capacitors, connectors and such. So gonna get started constructing the circuit. So I've got the board constructed. I figured the video is becoming long enough already, so I didn't show actually assembling this board, but it is completed. I haven't tested it yet. So just an overview again. We've got the RF input here. So this is where we put the antenna. This one right here is the this is the oscillator input, the local oscillator. So we'll put our function generator output right here, and then here is the output of the mixer. Then we'll hook that into the next stage, which will be the filter and amplifier. So now that I've got this constructed, let's go test it. So I've got the board sitting here now on the other bench, and there's a few things I want to test before I insert the mixer chip. And so like I want to test to make sure this filter works here, this the input filter, and I want to make sure that the this potentiometer here is adjusted so that way, well, because this to measure this signal, the signal I need to measure here is difficult to measure on this board with that chip in there. So I'm just gonna probe that right there and make sure that's the right level. There shouldn't be any shorts. There's only like one small area where there's 5 volts over here. So I think otherwise, as long as this is working fine, this is working fine, then we can put the chip in there and make sure that the whole circuit is working fine. So to test the input filter, I've set up the function generator to output a frequency sweep from the beginning to the end of the AM broadcast band, and those frequencies are shown here. So let's turn that on. Just press OK here, turn that on, and see, and we'll probe the input pin to the mixer chip on the socket to make sure that we can see that sweep. So here's the antenna input. I've got that hooked up to the function generator, and here is my probe for the oscilloscope. I'll just put that right there. Then we'll take a look at the oscilloscope and make sure that we're seeing the sweep. And there is the output of the filter. So we're seeing the frequency sweep, and it doesn't seem to be attenuating any frequencies more than others. So looks like it's working. So now we're going to adjust this potentiometer right here, so that way the oscillator pin of the mixer is getting about 200 to 300 millivolts peak to peak. So I've got the function generator set up to output a sine wave about 1.7 megahertz. So that is within the range of a local oscillator in the AM broadcast band. So I've got it set up for 1 volt peak to peak. So now I'm going to adjust this potentiometer so we get about 200 to 300 millivolts peak to peak. That should do. So here's the circuit we have set up. Now I've got 5 volts and ground going here. That's just coming from the breadboard. I've got my bench antenna hooked up here, and then I have the function generator still hooked up here, and this output here is connected to the oscilloscope, and then we'll take a look at that. So here's the output from the mixer, and looks just like what we got on the breadboard. So I'd say that this prototype board is working. Now here we have the mixer board, and I'm going to test this connected to the bench as an antenna, and the function generator as the local oscillator. Got a little tap here coming out, going to the breadboard part of the radio. This stuff is all the same from what you've seen previously. So Just gonna make sure that that works and sounds okay. And now I've set up the function generator, turned on the power supply. This connection here in my hand is a bit loose, so I'm just holding that. I'll just let you take a listen. So that's what it sounds like now with this new mixer board. So I'd say it sounds just as good. So now what I want to do is I want to take this design and start making an actual printed circuit board. So I'm gonna go to my computer and draw this in KiCad. So now I want to start drawing the PCB schematic, and I'm just going to draw the first part today, which is the part we just talked about, the input filter and the mixer. And as we go on each video, I will add on to this schematic, and then eventually I'll get a PCB made, and I'll assemble it, make sure that works. So first of all, I guess we'll just start at the beginning. And I'm just going to time lapse this so it doesn't take long for you. So I finished this part of the schematic. Here is the antenna input. That'll be an SMA connector. Here is the input filter. Here's the mixer and its coupling capacitors. Here is the oscillator input, and that's pretty much it for this part of the circuit. In the next video, I'll be talking about the filtering and amplification, and in that video I'll probably go in as much detail as I did this video. I'll show you how I built those parts, and well, mostly how I built the amplifier. The filtering is just a part I ordered. So anyway, I'll build that on the breadboard. I will build it on, then I'll build it on a prototype board, and then I will add it to the schematic. So I guess that wraps it up for this video. Thanks for watching.